All right, so here we have a word problem, so fun times, and I'm not a huge fan of how this word problem is represented. And here's why I'm not a huge fan of this. They have this capital C function that represents the cost, and then they have this lowercase c function that represents the marginal cost. So that can be a little confusing depending on how your eyesight is, but it does say like the marginal cost, blah, blah, blah. So they do say that, but again, there is a difference here between this capital C, that's the cost function, and then this lowercase c, that is the marginal cost. So that's the first thing to just note here. So you read through it and they basically tell us that the marginal cost is given by the C of P function, which is 0.06 per page. Now, what we need to remember in terms of our given information is that if they're telling us C of P is equal to 0.016, and that's the marginal cost. Remember that the marginal cost is the same thing as the derivative of that cost function. And I'm using like a little line here on the cost to make it a capital C. So that's the derivative of the cost function, and that's 0.016. Now, I always like to kind of make a note of what my variables represent because they represent different things on all these different questions. Here, P is the number of pages. So it's not the price, it's the number of pages that they're producing. All right, so they tell us what the derivative is of the cost function. They also tell us that if you have 1,000-page book, so that would mean if P is equal to 1,000, then the cost, the production cost, is equal to 23.32. So what you can do is you can take that statement and convert it into that means that my cost at 1,000 pages produced is equal to 23.32. So what they're giving us here is they're giving us a derivative and they're giving us an initial condition. That's the two pieces of information that we have. And then what we want to do is we want to find that cost function. And that cost function, again, is the original function. So the way that we're going to go from the derivative information backwards to the cost function is, as we did on the previous page, we are going to first integrate. So we're going to take our derivative. So our derivative equation is capital C prime of P is equal to 0.016. So we take that equation that has been given. So all of this is just like set up, trying to get our heads around what's going on here. And then we're going to start off by integrating the derivative. So to integrate the derivative, we just take the derivative equation, we apply our integral sign dx, and in this case, we're not going to use dx. And the reason why we're not going to use dx in this case is because the variable is p, so we're going to use dp. There's no x's in this problem, there's only p's, and so for that reason, we'll use dp. And then on the right-hand side, integrate, and then with respect to p. Now, just like we did on the previous page, this integral derivative, they're going to cancel because they undo each other. So that gives us capital C of P is equal to, and then here our 0.016, that's a standalone constant. And remember, with antiderivatives, that standalone constant is going to add on and get a plus P. All right, now usually what we do is we add a constant, but we usually represent that constant with a C, and over here we also have a C. So what I like to do, if there's too many C's in the problem, then I just call it C1 to represent the constant, or C sub 1. So you could still technically put the plus C here, but then it gets kind of confusing, like are we talking about the cost function, are we talking about the constant, who knows? So that's why I like to use a C sub 1 if it is confusing. All right, so we have integrated, that's good job. And then now what we're going to do is we're going to find our C. And the way we're going to find our C value is using that initial condition. So it was C of 1,000 was equal to 23.32. So here the input is 1,000. That's what we're going to plug in. So we'll plug in for the variable 1,000. All right, so again, this is kind of like the steps and then the work over here. So what we'll have is we have our general solution. Now we're going to try to find our C value. So we're going to plug in our P of 1,000. and then our constant is still there. And keep in mind what we're trying to do is we're trying to solve for the C sub 1, the constant. Now, our C of 1,000, that is this 23.32. So we plug in that 23.32. And then, of course, we would just multiply out, and just doing this for emphasis, we would multiply out the 0.016 times the 1,000, and that's going to give us 16. And then plus the C sub 1. And then here we actually have an equation to solve for. So to solve for C sub 1, we would subtract 16. So again, just for emphasis here, this 23.32 minus the 16 is going to give us 7.32 is equal to C sub 1. So again, the 7.32 is just coming from taking the 23.32 minus the 16. And that is our constant. Now, we found our C, we found our general solution, and so now step 3 is simply to combine it, put it together in one function. So this will be capital C of P is equal to 0.016P, and then plus our constant of 7.32. And that, specifically this right-hand side, is what you would type in on the homework software.